In this lecture, we're going to zoom in on private inheritance. And we're going to see that the class that does private inheritance is really selfish. Here is a simple structure we will be using in this lecture here. We will set up a person class which is going to act as our base class. We are going to inherit from this class privately and create an engineer class. And what this is going to do, it's going to take everything from the class person and make it private to the engineer class. So the M1 member variable, which was public in the base class, is going to be private to the engineer class. This is what we have here. The M2 member variable, which was protected, is going to become private in engineer. That's what we have here. And the M3 member variable, which was private to person class, is going to stay private to person in the eyes of engineer. This is the situation we have here. So the problem is going to really show up when somebody else tries to inherit from engineer. Because M1 and the M2 are now private to engineer, they will be inherited but still inaccessible to the civil engineer class here. M1 and M2 will be private to the engineer class, but M3 will be private to the base class, which is person. So hopefully you can see the message that if a member variable is private, it can't be inherited in any way. It doesn't matter which kind of inheritance you do. So starting from engineer, which has made M1 and M2 private to itself, it's no longer possible to forward these guys down in the inheritance hierarchy. Another way to look at this is to see that the engineer class is really selfish. It is saying, I am going to take everything I can get from my parent classes because I am inheriting privately, but nobody else will be able to take things from me because I'm going to make them private to myself. So even if civil engineer is doing public inheritance, that's not going to give him any access to these member variables, which are now private to the engineer class. Hopefully you can really see this, and private inheritance is going to really constrain what you can forward down to other classes that are going to be inheriting from you. This is the message I am trying to convey here. Okay, so here is the same example in code. We have our person class. It's going to have our member variables. We're going to have the full name, the age, and the address. They are going to have public, protected, and private access. We are going to inherit from person and create our engineer class. We are going to privately inherit from person, and this is going to take everything we get from person and make it private to the engineer class. And one exception is going to be what was already private to the base class, which is our person class here. This is going to still stay private to the person class, regardless of what kind of inheritance you do from person. But any other thing, if we have any member variable which are public or protected, or even if we have some member functions which are public or protected, everything is going to be private to the engineer class because we have done private inheritance here. So if we inherit from engineer and do any kind of inheritance, we are going to do the most relaxed kind of inheritance, which is going to keep the kind of access we had in the base class, but this is not going to improve anything. Everything is going to stay private to the engineer class. And the civil engineer is really not going to have any access to any member variable or member function that is inherited from the engineer class. And we are going to see this in a minute when we hit Visual Studio Code. So again, if a class is doing private inheritance, it's really another way to say this class is selfish. It's going to take everything it can from the parent class, but it's not going to forward nothing to downstream inheriting classes. And this is the setup I really want you to understand here. And only do private inheritance when you want this kind of behavior. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is closing in on private inheritance. We're going to zoom in on this and really understand the effects of doing private inheritance. We're going to grab the code from the previous lecture, and we're going to grab the engineer and the person class. These are going to be our starting point here. Make sure you grab the .vs Code folder if you are using VS Code with this course. That's going to give you the basic settings we need to do our C++ program. I am going to copy these guys down and put these in our current project. And again, make sure you have the main CPP file, the person class, and the engineer class. And these are going to be our starting point. So we're going to open this little guy in Visual Studio Code by dragging and dropping here. We're going to look at our main CPP program. We are not going to include nurse because we don't have this included here. And we can really take out everything we have in the main function. We're going to be adding our own thing here. We also don't need the player class here. We're just going to be using person and engineer. Let's look at the person class. It is going to have the member variables that we expect. We are going to have a public member variable, the full name, a protected member variable, mage, and a private member variable, maddress here. We are going to create an engineer class, which is going to privately inherit from person. So it is going to make everything private to itself. The engineer class is going to have a person part in it, but the member variables we get from the person class are going to be stripped down to private access level, except for the member variables which are already private in the base class, and that happens to be the address. So it doesn't matter which kind of inheritance you do, the maddress member variable is going to still be not accessible to inheriting classes. This is going to still be private to the base class, which is the person class here. So the full name is going to be stripped down to private access level in engineer. The age is also going to be stripped down to private access, and these are going to be private now to the engineer class. And any class that tries to inherit from engineer is not going to have access to these guys. So if we do any kind of inheritance from engineer, we want to have access to full name, we want to have access to mage, because these are going to be private to this class here. This is the setup we want to understand in this lecture. So what we're going to do, we're going to set up a new class which is going to inherit from our engineer class, and it is going to do public inheritance, and we're going to see how this works. We're going to create a civil engineer class which is going to inherit from engineer. So let's do this. We're going to create a header file for our civil engineer class, and we're going to create a CPP file. We are going to head over in our header file and put in the class. It's not going to be anything sophisticated. We're just going to have in our include guard, we're going to create a civil engineer class, which is going to publicly inherit from engineer. But remember, everything was made private to the engineer class. So even if we're doing public inheritance, the full name member variable is going to be private to engineer, the age is going to be private to engineer, and engineer won't have any access to these guys. But before we really play with that, we're going to put in our implementation in the CPP file. So let's put in the code here. We're going to put in the implementation, and we're going to have our constructor in place, but notice what happens on our output stream operator. The output stream operator is a friend of the civil engineer class, so it should have access to anything we have in our civil engineer class. But notice what is happening here. The get full name method is not working because it has been made private to the upstream class, which happens to be our engineer class. And we can't really access them, even if we know that they are really part of the interface of the person class. We have them as public members of the person class. But when the engineer class did private inheritance, it made everything that is not private to person private to itself. So these getters are going to be private to engineer. When the engineer does private inheritance, the member variables, which are public and protected, all these things are going to be stripped down to private access level. So they are going to be private to engineer, and any kind of inheritance you're going to do is not going to change that. they are going to be inherited as private to the engineer class. That's why we can't even call them from a function which is a friend of our civil engineer class. And we know that if you mark something as a friend, it's really going to have access to anything you have, including private members. But we can't call any of the members from the engineer class because everything is now private to the engineer class. This is what I want you to see. If you do private inheritance, this is going to really strip down anything from the upstream class and make that private to the class that is doing private inheritance. This is the message here. And again, if you go in any method of the civil engineer class and try to do any kind of access, for example, calling the get full name method is not going to bode well. We're going to see that this is inaccessible here. If we try to access M full name, for example, change this to be something else, let's say Daniel Gray, this is not going to work. If you try to access MH and change it to 45, for example, this is not going to work. We already know that the address is private to person, so we shouldn't really try to access it because it is inaccessible regardless of any kind of inheritance you do. But the members that were public from person can't be accessed from any class that is inheriting from person, even if we know that these things are public or protected in the person class. And this is really what I want you to see. If we try and build our program, we're going to get a bunch of compiler errors saying that we can't access these guys from our civil engineer class. We are going to use the GCC compiler here because it is our favorite. And we're going to see our compiler errors here. Okay, so we're going to get a bunch of errors. Let's go up and see all of them. We're going to get an error saying that get full name is inaccessible within the context of the civil engineer header class at line 13. We are calling this method. That's not going to work. We have another error here saying that the get full name method is not accessible from line 13 of the civil engineer header. Okay, it is really the same error, but if we go down, we see that we get a bunch of other errors. We have M full name, which is not accessible. We have M age, which is not accessible. We can't really do these kinds of things from the civil engineer class because all these are going to become private to the upstream class that did private inheritance. So let's take these out and show you that even if we can't access these guys, they are still part of our civil engineer class, and we're going to use a debugger to do that. I am going to take out these things, or I can comment them out and say that they are going to give you compiler errors. I think this is going to be more descriptive. So let's say compiler error. And access to the age is also going to give you a compiler error. And we're going to go down and show you that we're also going to have the same problem in our output stream operator. So if you really want your output stream operator to work here, what you can do is put some public members in the engineer class and make it give you access to the members that were eclipsed to private access in this class here. For example, you can return the full name. You see that we can access that here. You can return the age, but you still don't have access to the M address member variable because this is private to the person class. But I really don't even want to do this because doing this kind of design is sign of bad design in the first place. So if you need to do those kinds of getters and forward them down to inheriting classes, why not change the design in the first place and not do private inheritance here? For example, if you change this inheritance to protected or public, these members are going to be directly automatically forwarded down to any inheriting class. So just know that you can put in public getters that are going to give access to the full name and age, but you still won't be able to access the address member from the inheriting class because this is the design you achieve by marking something as private in the base class. If you want the address to be forwarded down, you might change the access level we have here and maybe make it protected or public. So this is the ideas I really want you to grasp. I am going to comment out the offended code here because I want you to be able to build this program and see that even if we can't access this get full name and get address members from inheriting classes, they are still part of our interface. We just can't have access to them because of the choices we have made in upstream classes. So what I am going to do, I am going to go in my main CPP file and I am going to create an engineer object. I will also include civil engineer here. Let's do that. And I am going to create an engineer object and I am going to create a civil engineer object. And I am going to just say done here. And I am going to put a breakpoint on line 12. We are going to use a debugger to really see that engineer objects and civil engineer objects still have a person part of them. We just can't access the interface that was eclipsed by the engineer class. So we are going to hit the run tab here and we are going to start our debugging session by clicking on the green button here. We are going to build our program, and if the build is good, we're going to plug the binary that was generated into our debugger, and we are going to hit our breakpoint in a minute. Once we hit our breakpoint, we are going to look at the local variables we have in the main function. We're going to see them on the left here. If we expand, we're going to see that we have an engineer1 object, and we have a civil engineer1 object. If we look at our engineer, we're going to see that we have a person part of this, which is our base class. And if we look at civil engineer, it's also going to have a base of engineer. So any civil engineer is also going to be an engineer, but the engineer part of civil engineer also has a person part of that. You should really see this information. And the main message I want to convey here is that all these objects have a person part of them. We just can't access that part in objects of our inheriting classes because of the design decisions we have made. Let's close this off now that you have seen this. And again, we are really working on this inheritance hierarchy. The base class is person, and it's going to have these member variables. But if we do private inheritance from the person class, anything that is not public is going to be eclipsed down to private level access. So any other class that is going to inherit from our engineer class now is not going to have direct access to these members because they are going to become private to this class here. And that's the experience we have if we try to use any of these methods and members we get from engineer. This is not going to work because they are now private to the engineer class. This is the message here. So the get full name, get age methods are not going to work if we try to use the contract count member, which comes from the engineer class. That's not also going to work. If we look in our header and try to use any of these members, we're going to get compiler errors because all these guys are now private to the engineer class. This is really all I wanted to share in this lecture. Let's head over to the CPP file and comment this out again because I don't want to leave you with these compiler errors. I hope you found this lecture informative and fun. We are going to stop here in this one. In the next one, we're going to see that we can actually resurrect some members back in scope if they were eclipsed by the kind of inheritance we did from an upstream class. Go ahead and finish up here and meet me there.